Hey everybody, welcome to 5.6. Here are a couple of extra examples just to go through and try. That might help you with some of the questions on the assignment that you have, and then we'll get to example C that's on the top of your paper in just a second. But first, let's go through and do. So what we're going to do is we're going to solve for x. It's in the exponent, and what we learned today in 5.6 is that we can rewrite exponents as logs. But first what I'm going to do is I'm going to divide by 4 and divide this by 4. Alright, so then I end up with 10 to the x equals 4650 divided by 4 is a 1162.5. Alright, so if you remember, how do we get 10, how do we get the x out of the exponent into like a normal size, right? We can take actually log of both sides. So we can say log of 10 to the x equals log of 1162.5. Alright, so then the log and the 10 cancel each other out, and you end up with x equals the log of 1162.5. And then typing that into your calculator, you get that x is going to be, well, I know that 10 to some power, 10 to the third power is 1,000, right? Because 10 squared is 100 times 10 is 1,000. So it's going to be a little bit more than 3. And in fact, it is 3.0654. About. Alright? So that would be x. X is about 3.0654. So if we get that, this will be true. Okay, so now let's look at this one and say, how is example B a little bit different than example A? Well, now my base is a little bit different. Now the base is 4 to the x equals 128, so the base is 4. So we've got a little bit of a problem. So what we're going to do is let's take the log of both sides. Alright, so this is what it should look like. So we can say this is 10 to the log 4, and then times x equals 10 to the log 128. So why does it look like that? Well, we can say that 10 to the log 4 equals 4, right? So if we want to write 4 to the x, we can rewrite this 4 as 10 to the log 4 to the x power. So we're just replacing the 4 with 10 to the log 4. So I guess I really don't need that other thing in there. Let's just erase this part. Oh, no, I said erase. That's what I wanted. There we go. That's better. So now we can erase that. And now what we can do is we can go back and look and say 10 log base 4 of x equals 10 log 128. So then we can actually, this is just multiplying, right? So that just means it's 10 x log 4 equals 10 log 128. How is this different? Well, all I did was got rid of the parentheses and put the x first, okay? So that means we could really write this as, since the bases are the same, x log 4 equals log 128, right? So now if I want to solve for x, divide by log 4, which is just a number, divide by log 4, which is just a number, and we end up with x equals log 128 divided by log 4. Alright, log 128, log 4. Notice how this is not the same as log of 128 divided by 4. There isn't that shortcut in here. We actually have to do log 128, that's a number, log 4, that's a different number, and then divide them. So when you divide them, you end up with x is about 3.5. Actually, it's exactly 3.5. So we don't need the about. We can say that is exactly 3.5. Alright, so there's example A and example B. Here comes example C. So here is example C. Alright, so it says an initial deposit of $500 is invested at 8.5% interest compounded annually. How long will it take until the balance grows to $800? So what we're going to do is we want to say, we know we started off with 500. We're going to say 500 times the interest, so we mean to know it's going up, so it's going to be 1 plus 0.085. We don't know what the time is, but we know we want to end up with $800, right? Okay, so what we're going to do first is we need to get this stuff all by itself. So I'm going to divide by 500, divide by 500, and we end up, let's get some lines here. I think that'll be easier than, okay, there we go. Divide by 500, and we end up with 1.085. I just added those together to the x equals 800 divided by 5 is 1.6. Okay, so now what I want to do is we want to be able to take the log of both parts. Now remember, the log, that kind of what we did on that example B, we said log 126 over log 4. There is, in fact, a change of base property. Change of base property just says if we want to change the base, we can do that. Or we can rewrite this in part of the calculator. We should be able to solve that. So I'll kind of show you the change of base property, so that way we can write something like this or like this a little bit differently with just the logs. Okay, so we're going to try and rewrite this. So what we can do is let's try and take the log of both sides from kind of what we figured out. This is the same as x should equal the log base 1 point, that's not log, I said log, but I didn't write log. So let's just slowly erase this thing and try again. Okay, so we can say log, and the base is 1.085 of the number 1.6. Right? Log base this thing of 1.6 equals x. There's some ways that you could say that. You could say log base this number of this thing equals x. We can say x equals log base this number of 1.6. Okay, so we could write it like that. Now the problem is we don't have a log base 1.085 in your calculator. So we could do this one of two ways. One, you can go to math, the math key on your graphing calculator, and then you can go to it's all caps log base, and then it will tell you that whole thing. All right, so then you can type it, and you can actually type in, it'll just kind of give this up as a little dash box, and then you can type in your numbers. That's one way to do it. The other way we can do it is the change of base property, which is we can say this is the same as log base 10, which is just log, of 1.6 divided by log base 10 of 1.085. All right, so you can type that into your calculator as well. It doesn't really matter which one you do as long as you do one of them, and you get an answer of 5.7613. So it would take about 6 years, a little less than 6 years. All right, so it takes us a little less than 6 years to get this balance of $800. All right, there you go. So good luck on your assignment.